Hi, Ronaldo. Can you hear me?
Yes, Osvaldo, how are you doing?
I'm fine. You? How was your day?
Good. We're doing good here with the team.
Okay, we are ready. We are going to start in 1 minute. Victor, are you?
Hello?
Hi,
Victor?
Victor.
Yeah, loud and clear.
Okay, so in 1 minute we can start.
Perfect.
I can see people already connected to the webinar. If they can see, you can see the screen and you have a good, please make your in the question section and let to know if you can hear well and see the presentation. Thank you. Okay, I think everybody can see the screen and hear the audio correctly. Okay, we can start right now. Thank you, Ronaldo. Thank you, Ryan, to be with us this time in this webinar, talking about the Genius technology, Wi-Fi 6, the new standard in Wi-Fi market. So right now, thank you, everybody, for your time to take this opportunity for us to take this webinar, and I hope you enjoy. Okay, Ronaldo, Ryan, thank you very much, and go ahead, please. Thank you.
Hi, everyone. This is Brian with EnGenius Technologies. I appreciate everybody joining us. I want to thank you, EPCOM, for having or putting this webinar together. And again, thanks for your time today. Today, we'll be talking about Wi-Fi 6, specifically with EnGenius and what we have to offer. Some of those things I want to talk about are the futures of Wi-Fi demands, Wi-Fi 6 technology just in general. We'll touch on that at a high level. I do have Renato's here to help with questions. I also have a couple engineers here also to help with any questions. So if you have any questions, by all means, you can ask. What I'll do is I'll save those questions to the end and we'll answer those questions. But if you have a question during the presentation, please ask those questions and we'll try to answer them all at the end. And then we'll talk about EnGenius's Wi-Fi 6 solutions. So with that said, let's begin. So Wi-Fi 6 demands, specifically for client density and or bandwidth. What I mean by client density is the number of devices that are connecting to Wi-Fi networks today and the bandwidth that they're utilizing or using when they're connected to the Wi-Fi network. So just to kind of give you an idea and a reference when we think about Wi-Fi. And so EnGenius is, let's hold on just a second, we have the sound. Okay, so sorry about that, everybody. It was a little sound issue right there. So just to give everybody a reference in regards to where we see client density increasing, the bandwidth that's being used increasing. In 2017, traffic breakdown was around, for wired, about 48% of overall traffic on networks. On the wireless side, we saw about 52%. So we're seeing more devices using Wi-Fi and cellular as a medium to communicate with one another or to communicate online. By 2022, the traffic dramatically changes, where wired traffic will only be 29%, and 71% of that traffic will be wireless in some sorts, either cellular and or Wi-Fi, and majority of it's Wi-Fi. So that shift to wireless traffic is dramatically growing, and we see this for a number of different reasons. Offload of cellular traffic is one of those big reasons. So I'll give you an example of that. When I'm in my car, I'm using cellular data, and when I get out of my car, I walk into the office, my phone switches over to the Wi-Fi network. So now I'm on Wi-Fi data, or using Wi-Fi data. And we typically see that with tablets and smartphones specifically, more so on smartphones. Another reason for this is just the avoidance of wiring just in general. I mean, the convenience of Wi-Fi is why we are talking about Wi-Fi today, because it's a very convenient medium for everybody to use. Another portion of that is cost. The avoidance of wiring a house or a building, there's a cost to that. The average cost to run wiring for a household for Cat 5 or Cat 6 is about $660 per household. In regards to buildings, on average, it can go anywhere from $2,000 to $5,000 for running Cat 5, Cat 6 cables. So the avoidance of wiring and the cost of wiring is a big reason for this change. Another reason for change is IoT connectivity. IoT connectivity, or smart device connectivity, is growing dramatically. Every device that you see within a household inside of a smart building, or a smart house, I should say, is wirelessly connecting, and they're connecting to your Wi-Fi networks. Your Wi-Fi networks are acting as backbones to all these wireless devices. So IoT, or smart devices, is a big reason for this dramatic change. And again, convenience of Wi-Fi, just the convenience of it is, again, like I said, why we're here. That's why EnGenius has been in business for 20 years. Just the convenience of it is just tremendous, and it's improved over time. And you'll learn a little more how it's improved over time when we talk about Wi-Fi 6 a little more. So when we actually design Wi-Fi networks, we consider the number of devices that are connecting typically, and how they will roam throughout a building or throughout a home in a number of different areas. Number of wireless devices per user, general applications we consider 2.5, which sounds like a kind of a funny number, 2.5. How can you have 2.5 devices? And that's just the math, how we've done it in the past. And typically when we're designing, we consider 2.5 devices per person. Higher capacity applications, such as maybe a stadium, or maybe a house of worship, or a hospital, you might want to consider 4 Wi-Fi devices per person. The reason we do this is we're trying to plan for worst case scenario in a lot of applications. So a major design cue that we take is the number of devices per user, and we consider that in our design when we design for Wi-Fi networks, and the number of access points we use within a network. This number per person, the wireless connected devices per person, is dramatically also growing. In 2017, they measured about 8 connected devices per person. Now, 8 connected devices, what I mean by that are wired and wireless, but both those numbers are growing. It's not just the number of wired, but also the number of wireless devices, and that's growing up to about 13 connected devices per person. So every person that walks into a network, specifically a Wi-Fi network, there's potential for 13 devices or less devices connecting to your network. That's per person. So if you think about everybody that's transferring over to wireless, and you think about the number of devices that are connecting to your network, that in itself is a huge demand, a huge stress on Wi-Fi and the technology that we're using today. The other factor is IoT. So, we're talking about everybody that's moving over to wireless. We're talking about the number of devices per person growing. This does not account for the number of smart devices that are connecting also. I'll give you a very simple example, and I always use my home as an example, so it relates to most listeners. My garage door is wireless. It connects to my wireless network. My doorbell is wireless. It connects to my wireless network. My Xbox connects. My PS2 connects. My refrigerator connects. My oven connects. My oven cooktop, or the hood, vent hood, connects. All wireless. All these devices in my home connect. If I count the number of devices in my house that wirelessly connect, I come up with a number around 25 devices of smart IoT devices that connect. That does not consider my laptops. That does not consider my kids' gaming consoles, the tablets, and so on. So the number of devices is being amplified by the number of IoT devices that are also connecting. Now, the IDC reported about 30 billion devices by 2020 and 80 billion devices by 2025 of IoT devices connecting to networks, specifically Wi-Fi networks. Cisco Visual Networks Index accounted for most of that connectivity coming from the machine-to-machine connections, which will grow the fastest of all wireless devices, about 2.5 times the fastest, and will be the majority. Smartphones will grow around second fastest, about 9%. Connected TVs will grow third fastest, it's about 7%. What we're trying to explain here is all these devices that are connecting. And so this is being amplified, compounded year after year, month after month. This is happening in the residential space, this is happening in the small, medium-sized business space, and it's happening in the enterprise space. The other factor is now you have all these wireless devices connecting. There's a larger demand for bandwidth. Everybody wants more bandwidth. And you know, from the time I started with EnGenius, when we were doing 802.11b all the way up until 802.11ac, what wireless has always been trying to achieve through these different standards, B, G, N, AC, 11a, is faster and faster speeds. We were always trying to be faster than the wired connection. And so we have achieved very great bandwidth with wireless. But now we have another issue. We have bandwidth mixed in with the number of devices connecting. Bandwidth demands are growing because we have HD video, we have dynamic content, we have 4K content, we have social media content. The current, or this graph should be updated. The average speed for Wi-Fi is 42.5 megabits per second, and that will move up to about 73 megabits per second on average. You'll notice in the chart that the average speed for cellular versus Wi-Fi speed, the dramatic differences between the two. This information was pulled from the visual index from Cisco. And so you can see that the speeds between Wi-Fi and cellular are much higher, and that's why a lot of people depend on Wi-Fi. So we have these major demands with these, with the number of devices, like I said, and the bandwidth. Some of the top applications that we see within basically tablets and smartphones. You have YouTube, Netflix, and browsers are the top three. The same thing is really for smartphones, but you're seeing Facebook, YouTube, and browsers. So basically social media. YouTube is normally the biggest one, and browsers are normally the biggest ones that we see in the offices today. How-to videos, these webinars show up on videos. There's a number of different things that show up on the within your networks, and the amount of bandwidth that is needed on these Wi-Fi networks. So just to give you some quick references, by 2022, Wi-Fi mobile devices will account for 71% of IP traffic. Connected devices will grow to 13.4 devices by 2022. The fixed IP traffic will grow at a compounded average growth rate of 24% between 2017 and 2022. That is huge. Wi-Fi connectivity is approximately 2.5 times faster than mobile data. Specifically, North America will experience the highest Wi-Fi speeds of 83.8 megabits per second by 2022. So it's dramatically growing in the US. It also is growing in other countries, but for the sake of this webinar, we're talking about North America and part of South America. IoT or smart devices will be about 51% of the total devices that are connecting by 2022. So to give you some idea of where Wi-Fi is headed and what the direction is, a lot of growth in regards to the connectivity, a lot of growth in regards to the bandwidth that is needed for all these connected devices. Where do we see the demand? We see these demands in a number of different areas. Like I said, all the way from the residential space all the way up to assisted living, hospitals, and K-12 private schools. We see it everywhere. If you go online today, you're seeing smart homes, you're seeing smart offices, you're seeing smart cafes. All these quote unquote smart things are these smart devices connecting, these IoT devices connecting, where we're seeing a lot of connections and bandwidth needs come from. Let's talk about Wi-Fi 6. So Wi-Fi 6, what is it? It is high efficiency Wi-Fi. The new 11AX standard, what's really important about this, it's built upon real world deployment of 802.11ac. So as I mentioned before, through the different standards of Wi-Fi, we've always been trying to achieve speed and obviously security. Speed and security have always been the major factors for these different standards as they came out, right? And there's different techniques and different standards to be able to achieve more speed and to have better security. 802.11ax or Wi-Fi 6 that it's known for now is about high efficiency. And as I mentioned, the importance here is that it was built upon real world deployments of 11ac. That's where the groundwork really started. They took enterprise cases of 11ac deployments and they said, okay, how can we improve Wi-Fi today? And they used these studies to create 11ax, and that's where we are today. This Wi-Fi 6 is designed to handle more connectivity and provide better averages of speed over more users, basically. There's many features within Wi-Fi 6 that are important, I would say. The most important, and Gabriel, who's one of our engineers, and Peter, who's also one of our engineers, I think they would agree. The most important feature of Wi-Fi 6 is OFDMA. OFDMA allows for better connectivity, better traffic management within the Wi-Fi network. OFDMA basically stands for orthogonal frequency division multiple access. You can Google that if you'd like. But it's basically a multi-user version of the OFDM that we're using today in 11ac, 11n, 11g, and I think that covers most of them. A and G, right? And so that's the version of OFDM digital modulation technology. Yeah, so A, G, and AC radios currently use OFDM for single user transmissions on a 802.11 frequency band, basically. But what OFDMA does is it enables more efficient channel use. It reduces overall latency between AP and client devices. A lot of people don't know this, but a lot of their interference actually comes from the client devices that are in the network. So you can imagine with all these connected devices, you're going to have more and more interference on your Wi-Fi networks. And so that's where OFDMA really kind of helps out. and it also provides backwards compatibility with 2.4 gigahertz and 5 gigahertz. So 802.11ax or Wi-Fi 6 operates on 2.4 gigahertz and 5 gigahertz. So OFDMA is allowing the medium our access points to communicate to more devices at the same time, rather than with 11AC and below, my access point will talk to one particular device at a time. And once they're done transmission, it will talk to another device and so on, and it will move to the next device. Whereas OFDMA will allow my access point to segment a part of the frequency band to talk to multiple devices at the same time. Multi-user MIMO. So we have uplink and downlink. And this is true for OFDMA. OFDMA will operate on the uplink and the downlink. But multi-user MIMO. Multi-user MIMO was really introduced in 11AC, Wave 2 specifically. A lot of people don't know that. We have 11AC Wave 1, 11AC Wave 2. When Wave 2 was completed, that's when multi-user MIMO really came into play. Now, multi-user MIMO hasn't really been utilized in the real world instances. We haven't found really good cases for that to be utilized, but it's still an important factor or a feature. Supports up to 8 client devices and provides greater network efficiency. It focuses the radio energy on specific users and ensures optimal signal and reception reliability. Now, to be able to use multi-user MIMO, the access point has to support it, and so does the client device. And you have to have good distance between the different clients to be able to, for this to perform well. So that's something that has to be considered. I would say where you would use multi-user MIMO are in particular cases where there's really no interference. There's just a few devices that are on the network, and you need large bandwidth, and that's when you would really use multi-user MIMO. You're going to use OFDMA more so than you would multi-user MIMO. Now, this within Wi-Fi 6, they will work together, but there's not a case out there yet that they're operating together or working together, because not everything is ratified yet. So that's a very big reason. So which is better? It really depends on the situation. I would lean towards OFDMA and a lot of the networks that we work in today. Two other features is 1024 QAM, which will boost throughput by 25% and provides greater reliability in shorter distances. Shorter distances, the very short distances, I would say the RSSI for actual really good throughput using QAM, higher modulation basically, is probably about -37 dB. So the signal has to be really, really good and really, really clean. The first generation 11AX radios will support 1024 QAM, which will also mean some new modulation and code schemes will be defined for the higher data rates. Very similar to 256 QAM, which is operating on 11AC. But definitely the signal noise threshold will be right around 37 to achieve the 25% more bandwidth. So that has to be a very clean RF environment with low noise floor and you have to be very close to the access point to achieve that kind of speed. But at the end of the day, you will see improved performance with the higher modulation. Longer OFDM symbols really enables shorter wait times between data transmissions and tolerates noise better. And that is really you're really going to see that improvement in the outdoor space more so than in the indoor space. I think you'll see it in the indoor space, but more so in the outdoor application, because it has a better resiliency in outdoor environments. So we see that more probably happening in point-to-point and point-to-multipoint. Maybe this is where this is really going to be a key feature for EnGenius specifically. Target wait time. Target wait time is basically, it's going to help reduce power consumption, schedules wait time, and extends client battery life of mobile devices and IoT devices. Really on the smart devices or the IoT device area, this is where this will really be important feature. Basically, AP and the device negotiate and define a specific time to access the medium, and then what that does is, say for example, I'll use my garage door as an example. It's not being used every time, but my garage door opener is checking in with my access point, say every 30 milliseconds, for example, or 100 milliseconds. With target wait time, and it's doing it, so my garage door is continuously asking for a request from my access point to say, hey, I'm still alive, I'm still here. With target wait time, the access point can negotiate when to speak to the garage door opener or vice versa. So there's less contention in the air, there's less interference in the air. And so that's where target wait time really helps. It helps with, like I said, battery life and also contention in the air. So there are two major things. So target wait time is one of those key features that we see helping in the IoT space or the smart device space. BSS coloring and spatial reuse also helps with contention, also helps with reutilizing the channel. So you can have multiple SSIDs operating on the same channel. If you're within the same SSID subset, you will be able to basically reuse a channel that is operating on another BSSID that is on a different network. And so you're able to reuse that channel. In today's world, a client device sees that that channel is being used by another network, not your network, but another network, and will wait to see when that is clear. Well, BSS coloring will help you reuse that channel and say, okay, you're on the same network with me. There's certain criteria that we've set. You can use this channel regardless of this neighboring access point and client device that are causing interference. Regardless of them, we can still use this channel and still operate and communicate based off of some criteria. So some things to know in regards to Wi-Fi 6 or 802.11ax. Again, it's high efficiency wireless communication. Wi-Fi 6 builds upon real world deployments of 11AC. That's really important because we actually used IE used real world instances of 11AC and based the foundations of 11ax based off of those studies. Wi-Fi 6 is designed to manage more traffic, improve average throughput for all users. Wi-Fi 6 is estimated to be ratified by the end of December 2019. It could happen a little bit earlier, but that was the latest that I've received. So that continuously updates. Wi-Fi 6 will operate again on 2.4 and 5 gigahertz. It is also backwards compatible with 802.11a, B, G, N, and AC, so you don't have to worry about backwards compatibility. And Wi-Fi 6 features on an access point will only work with Wi-Fi 6 client devices. So let me repeat that last one. So 11ax features, the time that you will see the benefits of those features that I just talked about are when you have a Wi-Fi 6 client device like the Samsung S10, which is Wi-Fi 6. That's when you see the benefits of all the features that we just talked about. However, all these new access points that we create, obviously they come with a new CPU, they come with the latest chipset, they come with the latest board technology, the latest memory technology, latest flash, and so on. With all those improvements, you are going to see improvements in your network in regards to speed and range. So you're going to see that with every new access point that you receive. You should anyway, right? What EnGenius really wanted to do is put Wi-Fi 6 in the hands of the SMB market. As I mentioned before, Wi-Fi 6 was really designed around enterprise deployments. The technology was created with enterprise level networks in mind. And so EnGenius sees that technology as being very critical in the SMB space. And so what we wanted to do is present Wi-Fi 6 to the SMB industry. And so, as you may or may not know, for the last 20 years, we've served that industry. And so we wanted to put that next generation cutting edge technology in the hands of the SMB. We wanted to fast track those SMBs to take advantage of those most sophisticated wireless technologies to date. And now, if you're an early adopter or you're future proofing, you can take advantage of those devices with the access points that we're producing today. So EnGenius's Wi-Fi 6 access points to help meet those demands of the number of clients being connected, the bandwidth requirements that is needed on each of these devices. We have a couple solutions for that. All of our access points are equipped with the Qualcomm's newest chipset, and that's for the EWS 357 AP and the EWS 377 AP, which features Wi-Fi 6 or 802.11ax technology, which will help deepen and expand capabilities of Wi-Fi, as well as fortify small and mid-sized business networks with stronger, steadier, more efficient wireless connections. And so we'll talk about these two particular models in a little more detail. So this is the industry's first SMB 11AX access point. It's a 2x2 setup. Regarding the 2x2 is there's 4 antennas internally, 2 for the 2.4 and 2 for the 5 gigahertz. We built this because it matches the needs of the majority of today's clients, which are 1x1 and 2x2. A majority of the mobile phones that are out there are 2x2 designs, and a lot of them are 1x1. There really are no 3x3 design client devices or 4x4 antenna devices out there, or client devices. If you're getting into 3x3 and 4x4, you're really talking about a very high-end laptop in most cases. So you're really dealing with 1x1 and 2x2 antenna design. So we wanted to come out with an access point that had a 2x2 design. This enables advancements within the network with demanding a significant restructuring of the switching fabric. This is a 1 gigabit port, so it can go into any network. You don't have to do any extra. You don't have to change out your switches. You don't have to buy new PoE injectors. This is an 802.3 AT compliant, AF compliant access point, so it can go right into the network today. It supports existing and future device application needs. It is backwards compatible with legacy Wi-Fi such as A, B, G, and N, and also AC. So it really re-energizes the capacity and reach of 2.4 and 5 gigahertz, specifically on the 2.4 gigahertz because you're getting all this technology on the 2.4 gigahertz. And for 11AC, as everybody probably knows, it only operates on 5 gigahertz, whereas 11AX operates on 2.4 and 5 gigahertz. So you want to keep that in mind. So what does the 357 have? This is a managed access point. This access point can be managed in a number of different ways. It supports AC, A, G, N, and AX. You will see improvements with this particular device, the 357 and the 377, which I'll talk about in regards to performance and range and performance speed. There's multiple third-party testing done on the 357 and 377 that have seen really good improvements in regards to range and speed, and then the number of devices connected. This supports 1200 megabits on the 5 gigahertz and 574 megabits on the 2.4 gigahertz. Like I said, it's a 2x2 internal 3 dBi antenna design. There's one Ethernet jack on that. That's a gigabit. It's PoE support. It's 802.3 AF compliant. It does have an adjustable radio within that, so you can turn down the radio, turn up the radio if you need to. It only consumes 12.5 watts of power, which is very minimal for 11AX access point. And that's a repeat in the spec. It's compliant. It supports WPA2. It will support WPA3 when that is ratified. That is not ratified yet. And it can be configured and monitored under our software, network management software, EasyMaster. You can manage one of these devices or thousands of these devices across subnets or across different sites. It does support captive portal, guest networking, and it does have seamless roaming and bandwidth control per SSID and per user. So you want to keep that in mind. The other solution that we have is our 4x4 access point. This is pretty much my personal choice, my go-to for an access point when we're deploying in applications. Now, I just said that you need and I'm going to reiterate this, you need 11AX client device and 11AX access point to take full, to really see the improvements of 11AX. But with that said, as I mentioned, the board redesign, the memory refresh, the latest CPU, the latest Qualcomm chipset will improve your overall performance in regards to range and speed, the number of devices that will connect. But the thing I'd like to mention, as devices are added into the network, say you have you have new access points 11AX, they're all 11AX, and you have a 11N, 11AC client devices on your network. As those devices are within your network and 11AX clients move into your network, your overall network will actually get better. And as more and more 11AX devices come into your network, the overall network will continue to get better and better. And as the 11N client devices drop off first, you'll see more improvement and more improvement. So you're future-proofing your network. So if your customers are considering a new refresh, this is a device that I would probably consider for a refresh in regards to your networks. This particular device meets today's future and high density demands, which obviously I stated at the beginning is becoming more relevant. It really enables those SMB customers with a solution for high concentrated Wi-Fi areas, such as large training rooms. Again, it supports existing and future devices and application needs, backwards compatible, and it's utilizing it on 2.4 and 5 gigahertz. So these are the two different solutions that we have. The overall feature set is very similar to the EWS 357 AP. It's a manageable AP. It supports AX. This provides you more speeds, up to 2,400 megabits per second on 5 gigahertz, 1,148 megabits on 2.4. This particular device is a 4x4 design, so it has 8 antennas, 4 on 2.4, 4 on 5. It has 1 gigabit and one 2.5 gig Ethernet port. So the Ethernet port on this supports a higher speed. This has an adjustable 23 dBm radio, so you can actually go a little bit higher on this particular radio in regards to output power. This is a 802.3 AT compliant. The power consumption on this particular device is only 17.5 watts, so more on the more than the 357, but for obvious reasons, it has more capabilities on throughput. It's handling more devices, more antennas, so that's why you have the higher power consumption. It will also support WPA2 and WPA3, and it's also a manageable device too. The devices, if you look at the lineup for EnGenius, all our devices have been very, very similar up until this point. We started to change the form factor. This is a thinner form factor, a little sleeker design for ceiling mount. So very clean, sleek form factor for this particular device. So just to give you a look at the actual device itself. And before we have questions, I wanted to mention that we will have an event in Dallas. Hopefully, there's some people local to Dallas. We will be launching the EnGenius Cloud, and we have an event for that. We have multiple events. It's a night event. It starts from 4:30 to 9:30 p.m. We have a location in Chicago, Dallas, and New Jersey. We're still trying to figure out where we're going to go in San Diego. I would specifically try to go to the Dallas event, and the reason I say that is we have our VP of engineering that will be there that designed every single little granular feature on the cloud, and we will also have Qualcomm, which is a very large chipset manufacturer. They will be speaking about 11AX, probably better than what I just did for you guys, but they can give you the very granular information and where the future of 11AX is going and some of the other things that they're doing at Qualcomm. So Qualcomm will be at the Dallas event, and it will be at a Topgolf location in Dallas. So if you're able to attend, that's great. You just have to register online, and you can do that at ingeniustech.com. So at this point, what I'll do is I'll open it up for any questions that you may have, and I want to thank you to EPCOM for having this webinar, and I want to thank everybody for joining, and hopefully you got something from this webinar today.
Thank you, Ryan, and thank you, Reynaldo. Thank you for your time and very good presentation and amazing technology for North American clients. If anyone has a question, we will share this presentation soon, and this presentation is already recorded. So we will share with you guys. If you have any question, please let us know in the question section. Email us, please. We will answer all the questions you have. Just take a minute to see if we have some questions. Reynaldo, something to add? Ryan, something to add?
Hi, this is Reynaldo. First of all, thank you for the opportunity for this webinar. I think Brian did an excellent job. Thank you, Brian. He's our PM for 11X. So it was an honor to have him. Usually he's really busy working with the cloud and 11X. So thank you, Brian. I really appreciated you joining and presenting the information about 11X.
I have a question here is, how does it work for barcode scanner in the warehouse? Jaime Solorza.
Sure. So I can answer that question. So it as long as your barcode scanner is of a Wi-Fi standard, and typically barcode scanners are 2.4 gigahertz, it will work with our access points. It's not going to take advantage if you're using an older scanner. It's not utilizing Wi-Fi 6 as the features of Wi-Fi 6 whatsoever. But yeah, it will work with these access points. But as you have new barcode standards come into play that are using 11AX, that's when you're going to start to see like the real benefit with barcode scanners in general. The other thing to consider is that if you have a lot of barcode scanners, along with the client devices that are going to be added per user, the IoT devices that are on your network, the Wi-Fi 6 access points are going to be future-proofing, right? So as client devices are added, IoT devices are added, and you're still using the same barcode scanners, you're going to see overall performance gains regardless, right? Because it's improving as the network as 11AX devices come online. It's improving and getting better as these devices come online. But it works with barcode standards, no problem. As long as it's 11B, 11G, 11N standard, it's totally fine, or 11AC standard, it's totally fine.
Okay, thank you, Ryan. And we can see another questions. Okay, we have another question with Jaime Solorza again. This is the standard better at mitigating in band and now the band interference?
What was the question again? I'm sorry.
Yes. Is this a standard better at mitigating in band and interference?
Yeah, I believe the answer is is it working better in regards to interference? I believe that was the question.
So it's better with contention because
Yeah.
interference and contention are two separate things.
Yeah.
I don't know if you hear me.
Yeah, so
With the smaller channels,
yes.
obviously.
Yep. No, it's okay. So now Gabriel had some input, but I think I understand what he was saying. Yes, definitely. One of the major things that we see in Wi-Fi networks today is the client devices are the biggest reasons for interference. And so, because they're always requesting time to share the medium. And with 11ax, what 11ax is, it deals with contention a lot better. It deals with all these requests from all these clients better using OFDMA specifically, compounded by later BSS coloring and spatial reuse and time wake time. All these things together all deal with traffic management and contention of devices. So when you have a lot of devices trying to communicate on today's world, they're all taking turns to communicate. With Wi-Fi 6 and the new technology, the new standard, it's able to divvy up or divide up the channel into smaller, what we call as resource units, to talk to different client devices and at different times, or at the same time, I should not say, not different times, but the same time. Let me give you an example of that. So for example, if my laptop is communicating to an access point, my laptop's going to utilize maybe 50% of the channel as an example. Whereas a phone, maybe not a phone, like an IoT device, like a doorbell, wants to utilize maybe a very small portion of that channel. Now, if my laptop is, I'm trying to watch a how-to video on YouTube, I want to use half the channel basically, and I have this doorbell that wants to use just a portion of the doorbell. In today's world, the doorbell has as much right to communicate on the medium as the laptop basically. It's using the whole channel for that little bit of information it's trying to send. So the doorbell goes, hey, I need to do a health check with you and say, hey, I'm still alive and I'm still working, but I'm going to use up the whole channel to be able to make that communication. And the amount of data I'm going to send is a very small portion of that data. And so my laptop sits there and waits for this communication to happen before I can get the medium to use it to do my how-to video on YouTube. So I sit there and I wait. And that's 11AC and everything below that. With 11ax, what 11ax access point will do, it will negotiate the amount of channel that it needs with the doorbell and with the laptop, and it will allocate the channel width based on the amount of information that it needs. So the laptop will take half the channel, and then the doorbell will take a small portion of the second half of the channel. And by the way, I can now communicate to other devices and slice up the rest of the channel for those devices. And I will communicate to all of them at the same time, and vice versa. They can communicate all back using that same amount of channel on the downlink and the uplink. So what you're doing with that is you have more efficient channel use, less contention in the air. Hopefully that answers that question.
Okay, you can use you can use technology and want to have capacity, multiple use, because right now everybody wants more bandwidth and more in the more devices. For example, in a hotel, in a host cafe, in the office, in the building, you can use this technology. First of all, increase all the speed of all devices. And also to support the new technologies in smartphones. So as you know, the business, the market of the smartphone is growing now very quickly. So coming from when you stand in AC and the new standards as well, you already have the infrastructure already to support the newest devices and also the legacy devices as well, to increase your bandwidth, and at the same time you increase your capacity using the Mimo technology and all that technology that Ryan explains. Okay, thank you everyone for your time to take this webinar. Amazing technology. So we have all the products in stock in Adcom. Please ask to your sales rep to follow you without problem. So thank you, Reynaldo, to give us this webinar. Thanks again, Brian, for your amazing presentation and amazing technology as well. So if you have more questions, please let us know. We will share this presentation and we will share with you an email to mail us. Okay, something to add?
Yeah, I just want to thank EPCOM and everybody for joining today.
Yeah, thank you, Brian. Thank you, Osvaldo, Epcom, and everyone that joined. Any question, please let us know. We're here to help.
Yeah, thank you. Please don't hesitate to contact us and you have any questions. So this technology can compete with the highest and level in the access point market. So Ingenious is pioneer of the newest technology in this case. Okay, thank you everyone. So we hope you enjoy this webinar. Thanks. Have a wonderful day. Thank you. Bye bye.